All right, so we have another matrix here. Actually, this is not a matrix, it's a system. We're going to turn it into a matrix to solve it. Solving meaning find where they cross, where these three-dimensional lines cross, where they intersect. Okay. So, step one, we form a matrix. Going to have row 1, row 2, and row 3, because this has row 1, row 2, and row 3. And it has 4 columns, which is why this is called a 3x4 system. The X column, the Y column, the Z column, and the number constant. These numbers are called constants because they're not with a variable. So this is the X column, the Y column, the Z column, and the constant column. Okay, I'm going to write down the numbers. And probably the best way to not make mistakes is to go out of order like this. Because it's so easy to make a mistake copying. Okay, and then I double check. Okay. Now, I need to put a 0 in that position. I need to come up with a strategy so that 8 plus something equals 0. And it's easy to turn 2 into -8 because 2 goes into 8 evenly. So here's what I'm going to do. Here's my recipe. It's kind of appropriate that that should be blue and that should be blue. Okay, I'm going to leave row 1 the way it is, but I'm going to multiply all the numbers in row 2 by -4. So that I'll get a -8 right there, and then I can add 8 plus -8, and I'll get 0. So, row 1 is 8, -1, 2, and 20. And row 2, I'm going to multiply by -4. So -4 times 2 is -8. -4 times 1 is -4. -4 times -1 is +4. And negative 4 times negative 3 is positive 12. And then I add together. 8 plus negative 8, or 8 minus 8, is 0. Negative 1 plus negative 4 is negative 5. 2 plus 4 is 6. 20 plus 12 is 32. And this is my new row 2. So, matrix number 2. Row 1, row 2, row 3. This is my new row 2. I try to put that in first so I don't forget. And then I go back to the matrix before and I copy down row 1 and row 3. Okay. Now, I need to put a 0 in this position. So I want to think about what is the smallest number I can think of that 8 and 6, I know there's a negative sign in front of the 6, but that 8 and 6 will both go into evenly. And the smallest number I can think of is 24. Because 3 times 8 is 24 and 4 times 6 is 24. So now I'm going to get to multiply row 1 and row 3 by something, because if I can make this positive 24 and this negative 24, then I'll have 24 minus 24, and that's 0. So my recipe is going to be 3 times row 1 plus 4 times row 2. Notice I don't have to make it negative because this is already negative. This is already positive. So I don't have to worry about making the signs opposite. The signs are already opposite. So 3 times row 1, I want to do that in black though, so it's easier. 3 times row 1. It's going to be 3 times 8 is 24. 3 times negative 1 is negative 3. 3 times 2 is 6. 3 times 20 is 60. And 4 times row 2. 4 times negative 6. 4 times negative 6 is negative 24. 4 times 1 is 4. 4 times 3 is 12. And 4 times negative 7 is negative 28. (24) minus 24 is 0. Negative 3 plus 4 is 1. 6 plus 12 is 18. And 60 minus 28, let's see, 10 minus 8 is 2. And 5 minus 2 is 3. So this is going to be 32. And this is going to be my new row 3. I called that row 2. This is not row 2, it's row 3. Row 1 and row 3. Good grief. All right, now. Matrix 3. Row 1, row 2, row 3. This is my new row 3. 0, 1, 18, 32. All right, and row 2 was 0, is 0, negative 5, 6, and 32. You're kidding me. And row 1 is 8, negative 1, 2, and 20. Okay. Now, we're almost done with the row operations. Zero. Okay. I have to put a 0 in this position. If I multiply row 3 by 5, then I'll have negative 5 plus 5, and that's 0. Okay, so my recipe is going to be row 2 as it is, plus 5 times row 3. So row 2 is 0, negative 5, 6, and 32. And 5 times row 3 is 0. 5 times 1 is 5. 5 times 18, I think is 90. Yep. And 5 times 32 is 160. This is terrible. Oh well. I personally hate large numbers. 0, 0, 96, 192. And this is going to be my new row 3. Notice there are 2 new row 3s because I need 2 zeros there. And this is matrix 4, and this is our last matrix. Zero, 0, 96, and 192. And then I copy row 2 and row 1 from the previous matrix. 0, -5, 6, and 32. And 8, -1, 2, and 20. This is our last matrix. After this, we do this. Okay, so we have turned our matrix back into the system it really is. And now we're going to start back solving, working with row 3 first, and then row 2, and then row 1. So first thing, 96Z equals 192. Divide by 96, divide by 96. Calculator. One, 9, 2 divided by 96. Whew. Okay, Z equals 2. Now I go up to row 2. -5y plus 6 times 2 equals 32. -5y plus 12 equals 32. Subtract 12. That's, okay, I'll be good. Minus 12, minus 12. 12 minus 12 is 0. -5y equals 20. Divide by -5, divide by -5. Boom, 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 boom. Y equals -4. Now, row 1. We're going to have 8x, here, row 1. 8x minus 1y plus 2z equals 20. So that'll be 8x negative 4. Okay. Y is negative 4. Negative 1 times negative 4 plus 2 times 2 equals 20. 8x plus 4 equals 20. 8x plus 8 equals 8x plus 8 equals 20. Subtract 8, subtract 8. 8x equals 12. Divide by 8. Divide by 8. So x is going to equal 4 goes into both of these, so I can divide both by 4, or I can do it in the calculator. That'll be 3/2. If I do it in the calculator, I would say 12/8, 12 divided by 8, math, frac, enter. And the answer is 3/2. So we write in the answer in this form, x, y, z, where z is 2, y is negative 4, and x is 3/2. And there you go. So it's the same method, the same steps over and over and over again, because we're using the method called Gaussian elimination. Gauss-Jordan elimination requires that you get more zeros. So you have to do more row operations. That is, they go on longer. For a longer time. All right, let's pull back, pull back. So here was the system. We take our original system, we turn it into a matrix. Then we start doing row operations to put a 0 here, a 0 here, and a 0 here, until we get our lower triangle of zeros. That's how you know you're done, if you're using Gaussian elimination. Then it's just a matter of writing out matrix 4 as a system, and then back solving. First you find z, because it's the easiest. Once you know z, you find y. Once you know z and y, you find x, and then you write them down in x, y, z form.